Hello everyone, and welcome to a new video on the number one topic that people get wrong about Kubernetes, and that is resource management. Today we're looking at CPU and memory requests. What are requests fundamentally? What are they used for? Why are they important? And what do people get wrong about them? And this is part one of a multi-part video where we'll look at everything about Kubernetes resource management. Okay, so to get started, why do we even need a concept like requests? And for this video, I'm going to focus mostly on CPU, but everything I say applies to memory as well. So let's say I have here two nodes, node 1 and node 2. Each has 3 CPU, each has a few pods running on it. And then along comes a new pod, and we have to decide where we should schedule this pod. Should this pod go over here, or should this pod go over here? And obviously, we don't want to put too many things that are CPU heavy on the same node. So we like it to be balanced, and we like each pod to be on a node where it can get its fair share of CPU. Each pod might require a different amount of CPU, so I shouldn't just count up these pods and say there are 2 pods here, 2 pods here. It doesn't matter. Maybe, for example, pod D actually uses a ton of CPU and the rest don't use CPU at all. So one strategy that I could use is I could look at what the pods are doing right now, how much CPU are they using at this exact moment, and then according to that, I schedule pod E. That's not what Kubernetes does. It's a good strategy, or it's a viable strategy. It's not what Kubernetes does, because if right now there's a spike, then we'll put this pod in the wrong place. And then if we put it in the wrong place and we made a mistake, there's a high cost to that mistake because we have to kick it off once it's already running, and that causes some downtime for this pod or for this microservice. So Kubernetes doesn't do that. Instead, what Kubernetes does is it forces you to define upfront how much CPU do we expect this pod to use, and that's called a CPU request. And so if we go over here, this is now what things look like. So let's say we have a few pods running. We'll just stick these over here. Each pod here has a certain request, so I'm representing that with the size of this rectangle. So we have here these 2 running, and then along comes a new pod, pod C, and Kubernetes needs to decide where should it schedule this pod, and it looks and it says, oh, okay, there's actually room over here. I can fit this inside. This pod, it claims, before it's even started running, it claims that it needs 1.5 CPU. Here I have 3 CPU, 1.5 CPU is taken up by this pod, and this pod is claiming it needs 1.5 CPU, so we can fit it in over here, or we can fit it in over here. It actually doesn't matter. So we'll stick that over here. And then along comes a new pod. And this pod D says it wants 3 CPU. That's the request. That's the expectation that you define in advance of how much CPU this pod claims that it's going to need. And we look at this, and Kubernetes says, okay, no, I can't schedule that here. There's no room. And I can't schedule that here either. There's no room. This node has 3 CPU. 1.5 CPU is being reserved for this pod. And this pod needs 3 CPU. So this is unschedulable. And this is something we've also tried to show in Robusta. That's the open source multi-cluster Kubernetes monitoring platform I look at. So I'll show you an example of what this looks like in the real world. Let's say here I have an application running and I update the CPU request, and here I put a massive, gigantic 25 CPUs that I'm claiming this application needs. And right after that, we now have, if I just go back over here, right after I updated that, let me move this over. You can see now we have here failed scheduling event from Kubernetes, and this pod cannot be scheduled. 0 or 3 nodes are available. 3 insufficient CPU. Okay, so if I jump back over here, that's essentially what's going on over here. We have a pod that needs 3 CPUs, can't be scheduled to either node. I want to emphasize something that's super important that I can't emphasize enough. These pods, all these pods, they might be using 0 CPU right now. The request here, it doesn't represent how much CPU is actually being used. So I might be unable to schedule this, even though no one in the cluster is using CPU, because the request is essentially how much each one of these pods is saying, save for me in advance. So in essence, CPU requests and memory requests as well have 2 purposes. It's a dual purpose thing. Purpose number 1, to give a prediction, an estimation in advance of how much CPU this pod claims that it'll want. And that's used for scheduling. That's used to decide where we should put this, what node we should put it on. Purpose number 2 of CPU requests is to reserve that much CPU. So it's not just used for scheduling. When these pods are actually running on these nodes, like take pod B here, it says I want 1.5 CPU. That's my request. So 1.5 CPU is reserved for this pod, and no one else can come and steal that CPU. That's why we can't put this over here, because if we put this on the same node, then we'd essentially be promising pod B 1.5 CPU. We'd be promising pod D 3 CPU. In total, that's 4.5 CPU. And there isn't enough CPU on the node to give each pod that guarantee. So a CPU request, and same goes for a memory request. It's one, a guarantee that you will get at least this much CPU, and two, it's used for scheduling to determine where we should put stuff. And the CPU request has no connection in practice to the maximum amount of CPU. This pod is running on this node, and on this node there are 3 CPUs available. So this pod might use more than 1.5. It might use 3 CPU, it might use 2 CPU, it might use 0 CPU. But it's guaranteed that it has at least 1.5 CPU available. And that's the core concept of a CPU request, and the same also goes for memory. And one other thing that I just want to add on here is that nodes will also reserve some CPU for themselves. That's called node allocatable, or actually it's the opposite of node allocatable. And that's essentially stuff that the node is reserving for itself to run all the different system stuff. And I apologize for the noise in the background. That's my cat saying hello. She doesn't like node allocatable either. And if you look here, for example, in Robusta, then you can see that some nodes are actually reserving a whole lot of space for themselves. And you can see here how much is available on each node, how much is allocatable. If I click, I can see what's actually running here, and so on. So this is part 1 of a multi-part video series, and next up we're going to speak about limits, and then we're going to speak after that about what people often get wrong, and then we're going to speak about the correct strategies for determining CPU requests and limits, and same for memory. So I hope you enjoyed this, and looking forward to your comments.